Welcome to Tech First, everybody. Today, I am going to talk about machine learning end-to-end pipeline, how to build the end-to-end pipeline using MLOS platform of Line. I am the product manager of MLU. My name is Hyeong. It's a pleasure to meet you all. Before I begin my presentation, I would like to show you a piece of artwork that won the first prize in the Colorado competition. It is titled Space Opera Theater, and it is a piece that depicts the opera in future space, outer space. Well, in fact, this is created by an AI program with a text description. It was created only within seconds, and so an artist has not brushed a paintbrush even once for this artwork. So machine learning model is showing great performance in various aspects. And many people will understand that a lot of resource, time, and energy has been put in to create such great model. So on a rainy day, if I want to go shopping, if I want to go to a coffee shop, how can it be predicted? Is it going to be simpler or less simple to predict? Does it require only one model? It is not true. Even creating a small model like this requires a full infrastructure, and all of these processes will have to be run. So the skills to create a model are as follows. Model developers, are you okay? As you have seen, in order to run a machine learning model, we can predict lots of stumbling blocks. Let's see how these stumbling blocks are overcome in line and how we can focus on developing in order to improve performance. So today, my presentation is on machine learning pipeline. So I would like to first start off with explaining what machine learning pipeline is. Machine learning pipeline deals with data extraction, model training, model evaluation, and model deployment. It is a series of processes to enable machine learning. Teams that adopt machine learning, they create a manual workflow like this. So the local data is collected and then it is all written down on a notebook file like this. And then the local notebook file is run and then it is sent to the service engineer. And the model developer and the service developer engages in this conversation. It's a new model. Well, the model's not working. Oh, that's weird. Well, it's working on my side. What version of Python are you using? I use 3.8. Well, can I have the entire requirement? Is this something familiar to you? As you can see, this workflow is unnecessary conversation. It is also very manual and very basic. It is difficult to repeat the process and to document and to record this kind of process is difficult. And when the repetition is accelerated without any testing or monitoring, many trouble could arise. So model development and model performance improvement requires a lot of time, but we're losing so much time on these kind of conversations. So we need an automated machine learning pipeline. As you can see on the screen, the data and the model has to be managed in the center, and there has to be lots of storage to store the history. So creation and distribution has to be automated, and it has to be scheduled as well. And not as a model, but as a pipeline we need to communicate. So my explanation and workflow will not be sufficient to give you a clear idea. So I want to delve into the actual case where we have applied MLU, which is Line's MLOps platform, how the pipelines were automated and how the automation process was improved. So the Line's Voom for You is a recommendation space for recommending contents for users. It's customized based on contents that the user used, and when the user selects the contents, it continuously provides contents that the user will like. And this is where we use the machine learning recommendation model. So the candidates for recommendation for the user is created, and based on the feedback and quality, data is verified and filtered. And based on that data, various embedding processes will be done and then will be gone through, and then the model will be learned and distributed. So in the post, we receive feedback from the user, and we apply the result and continuously improve the performance to provide better recommendation posts. What's most important in the recommendation model is the feedback is applied to the user feedback model so that the user can have a continuous experience.
So the For You model has to be updated at regular hours. And the results comes from multiple models, not from a single model. So a comprehensive result is provided to the users. So we had to schedule tens of model pipelines at regular hours. Multiple models affect a single result. On the other hand, one result can affect multiple results. One model could affect multiple results. So we have to see which recommendation results are introduced, and we have to see the dependency. We have to manage the data and model versions and check the histories. And when a failure occurs in a single model, the failure had propagated to the whole model. So we needed an environment where we could package each machine learning model into independent micro services. However, those who are not well accustomed to machine learning models, developing and building these environments would be a very difficult thing. They had to build a learning model. So we need to create tools that made APIs and containerize the models with a few lines of commands. And model training and serving requires massive GPU resources, so we needed flexible and optimized algorithm that can make use of GPU resources efficiently. And the team developers have a discrete environment, so that causes costs and a lot of failures. So we had to resolve these issues. So we used MLU to resolve these issues one by one. First, in MLU's cloud server environment, we carried out data pre-processing, model training, and verification. MLU provides SSH features so that Jupyter Lab code server and local IDEs could be available. So development can be carried out in the same environment as local, but MLU resources and shared repository could be used just as in the online environment. And the development is done on top of the Docker-based image provided by MLU, and custom image is created and shared within the project team, so all the team members could develop in the same requirement environment. And across the processes for model training, logging and tracking had been stored in the ML flow. So the connected data set parameter and training scales and performances were managed efficiently. And packaging used Bento ML, and automatically Dockerizing and API creation have been conducted, and server resources scale in and scale out have been managed. So model developers, even without any engineering knowledge, could optimize and use GPU resources efficiently. And the whole workflow was automated and scheduled using Airflow. And Python-based Airflow could be challenging for model developers. So for those model developers, the custom operators and GUI design tools could be used, so they could build pipelines even without writing a single code. And when deploying models, model developers do not have to intervene because models will go through tens of rounds of tests automatically, and optimized server environment will be found, and models could be served reliably in an environment where scaling and load balancing are conducted automatically. And in building the whole pipeline, in the UI environment provided by the MLU portal, only with a few clicks, a project can be created fast and easily, and instances could be created individually. Not only building pipelines, the whole development process could be shared and communicated with all team members. And after serving at production level, monitoring could be checked by visualization. And by adopting the MLU, many problems of VOOM recommendation model could be resolved. On top of that, in order to operate the VOOM recommendation service, only a single cloud server could replace the previously operated tens of servers. And all processes have been automated, so we didn't need to add more admins, and the failures have dropped significantly. So at the end of the day, we could focus more on model performance improvement. So in developing machine learning model, when MLU was used, model developers no longer had to face problems in infrastructure building, which means that they didn't have to care what Kubernetes is or what kind of GPUs they have to use, because MLU have already built the most optimum infrastructure environment, so they could focus on data analysis and model development. And they didn't have to install or use the open platforms such as Airflow or Bento ML. They can easily use MLU's centralized environment to create instances and share the same environment with team members. And this whole process do not require installation or code writing. Just using the intuitive UI provided by MLU portal, the pipeline can be built very easily. MLU supports not only the VOOM recommendation model, it provides support to build pipelines for machine learning model teams. Based on cost estimation criteria of cloud provider A, we provide support for model infrastructure building with 50 billion won's worth of cluster resources. And all global affiliates of LINE, such as in Japan, Thailand, Taiwan, 300 or more machine learning model development teams are using LINE's MLOps environment. So MLU is running more than 300 automated pipelines, and 107 machine learning models are served reliably at production level through the MLU. And so far, we have focused on machine learning's end-to-end pipeline building. We have gone one step further, and MLU is now aiming at creating a machine learning ecosystem which is flexible and scalable. First, we tried to create a public model repository to share and use the lines model and data set. So we provide that space, and also we manage the data efficiently and create the quality data. And to make this available, we are building a new pipeline. And we are also trying to create a vibrant community where anybody can discuss and share the knowledge about models and data. So we are trying to create this machine learning ecosystem. And today, I would like to introduce repository which shares lines model and dataset. Yesterday, MLU Marketplace has been released. Why don't we watch the demo together? So let's see, MLU Marketplace shares and manages the models. First, click the Create button and write down the model name and check if you're going to make it public, and then create the model. Then, as you can see from this screen, the models repository is created in the marketplace. Copy the created address and clone the repository in the MLU's notebook server and train the model in that folder. When the model training is concluded, then create a README file to introduce the model. And upload the models and the files at the repository. And let's go back to the marketplace screen. We can see the model introduction in the README file. In the marketplace, repositories can be created easily and models can be efficiently managed, and anyone can share the model that I have made. And Marketplace also provides the space where model is demonstrated, and we call that the showroom. So we're going to create the showroom. I'm going to create a demo page that sketches a photo. So we insert the title and upload the image and select the SDK that will build the model, and we're going to create the showroom. Now we have the repository space created. Now in the MLU notebook server, we clone the repository and write the code that we are going to demo the model. We define the model and also create examples of demo pages. When I create the showroom, I used the Gradio library to create the demo page. And then we push the code to the repository. Once I push that code, the showroom automatically creates the model building servers and executes the application. Now model is being built, and after a time, model will be built successfully, and you can query the demo page from the web. Now I'm going to use my picture. Now it turns into a very pretty sketch. So not only the model that I have built, the models built by other teams can be demonstrated very easily on the web. So what was your impression of Marketplace? Machine learning seemed to be a challenging technology, but I think now it will feel more easier for you. So MLU first began as an MLOps platform for model engineers. But now it serves not only the model developers, but also service engineers, marketers, and planners. So all people can use this when they would like to adopt machine learning. They can use machine learning easily and rapidly thanks to this environment. We're trying to build this environment continuously. Uh, we would like to go beyond a simple MLOps platform. We want to create the machine learning ecosystem, and I believe that would be the true machine learning end-to-end pipeline. Well, thank you for listening. I was Hong San-young.
Thank you very much. We're now going to take questions. So if you have any questions, please ask your questions. Those who are watching the presentations, press the question button at the bottom of your screen to send in your questions. From Yahoo Japan, we have Mr. Kuromatsu Nobiyuki. Mr. Kuromatsu, can you please introduce yourself? Thank you very much for introducing me. I am in charge of platform development and operation at Yahoo Japan. My name is Kuromatsu. Thank you very much. Well then, Mr. Kuromatsu, what was your question after listening to this session? Well, in my team, we develop in-house platforms. So it was very interesting to listen to your presentation. There were some parts that I was able to acknowledge, but some of the parts that I want to know more about. And the part that I want to know more about is packaging management. Bent ML was used in packaging. Not many companies use that. I want to know why you decided to use VentML. In the case of MLU, not only model engineers, but also service engineers and other people can use it, and we want as many people as possible to be able to use machine learning. In the case of vendor ML, we focused on localization, but also automation of API generation. And for using GPU, the vendor ML optimization was done. So the developers didn't have to pay attention to too much detail. So we used the vendor ML and library, and we're making good use of them. Thank you very much.
Next question. You said that model serving is supported. Oh, you didn't mention which one you use. Is it Bento ML or other tools? So we use Deeppocket. It is a platform, and it deploys and serves the model. This is a Lines platform, a homegrown platform, and it manages GPU infra and gets in charge of scheduling and uploading automatically. This is a separate platform that we use. Thank you very much. Thank you very much. That's very great. We have a Katu serve that takes charge of server at Yahoo, so I wanted to know the difference, and thank you for the answer.
So after serving phase in, I want to ask a question about model monitoring. On the slide, there is the serving resource usage rate and request. These things are monitored. And also for model performance, you are providing. Do you also provide monitoring for model performance? Yes, that is correct. As I have mentioned, in the deep pocket, we do deploy serving and monitoring. So yes, we do monitoring as well. And monitoring results are visualized as well.
So you mentioned visualization. There will be indicators, resource usage rate, and what about other else? Data distribution or modeling performance. Are you monitoring those as well? Yes, as you have mentioned, the requests volume to the model and the resources that the models are using are all visualized on the dashboard. And we are expanding the scope of our monitoring efforts. Thank you very much. And so you're saying that the monitoring will be done from many different angles. Yes, that's correct. Thank you. Next question. So about model training, you used ML Flow. In Yahoo Japan's platform, we are using ML Flow. What are the advantages you have experienced using ML Flow? The model's experiment results are automatically supported by ML Flow, so that was the biggest advantage. And among the test results, the development and production level history was also managed. So I think that was also the big advantage of ML Flow. Thank you.
So test data, not only you store it, but also you make use of it to identify parameters for performance improvement, or for when there is a trouble, you can go back to the past data. I think there can be many different use cases. So how are these used within your system? Yes, so we apply ML Flow for all of those cases as well. The advantages of ML Flow are used as much as we can within our company. Thank you very much. Well, I would like to ask you a question that is not about the MLU, not the internal system itself. So MLU, packaging the model and deploying, I think, can be done. But before packaging in the model development stage, so using a dedicated platform in the environment, how do you realize this part? The users mostly use the notebook server because it provides notebook server. That is the part that the users use the most. So within the MLU, there is the instance that we can set up the instance easily for a notebook server, and Docker base images are supported. So the users don't have to use their own notebook servers. They can make the instance within the MLU and train the model within the MLU. Thank you.
Well, thank you very much. I think that notebook is the most widely used platform. I think that's the same for Yahoo Japan. So the method would be different, but I think the environment would be the same. Thank you very much. Now, there are questions from the viewers. I would like to pick one. You have introduced Marketplace, MLU Marketplace, at the end of your presentation. It was about sharing public repository. So are you going to share it with the general users as well? Or is it just for the MLU public users? At present, it is shared to the Line Enterprise. However, we may have to consider whether we would like to share beyond that. Well, thank you very much. I hope that this could be shared with the general public so that we can use it as well. So I would like you to consider that very strongly. I hope that that day would come.
And I have received one more question for vendor ML, Bento ML. There is the paid and the free. The one used in the MLU, is that the free version or the paid version? We're using the free version. Thank you very much. Yes. I don't really know the differences between the features between the free bento and the paid bento. I guess that is what the person who asked the question wanted to know more about.
Next question. Just like MLU, if we want to develop an in-house platform and spread within the enterprise, I think we have to increase the number of users. We are collaborating with the users to create a platform within the Yahoo Japan, and we are now also making these platforms available. So I think Line has also thought a lot when creating this MLU and spreading to within the enterprise. What kind of considerations have you made? Well, at first, MLU seemed like a very challenging technology. However, we tried to make it more familiar and accessible by creating a user-friendly UI and around using infrastructure or optimizing GPU. We try to maximize automation so that users can access and create the environment easily. And that's what we are doing. And there's Pipe MLOps. That's where many users come together and share their models and knowledges and data. If that happens, then we can make more users use this pipeline. So we try to increase and expand this vibrant community.
Thank you very much. So it seems very difficult at first, but to make it easier to use or to distribute it further within the community, I think these were the parts that you have focused on. Thank you very much. I will take another question. So, as the background, at Yahoo Japan, we are seeing an increase of users for machine learning, but it takes up too much resource. So we are actually running out of resource. In MLU, when the number of users increase, so I guess that makes you happy, but at the same time, it can give you challenges as well. Does this ever happen? Well, as newer users come in, we are very thankful for them. But at the same time, we have to allocate more resource. So it is very difficult for us as well. But at Line, through MLU, many model developers and people who are interested in machine learning, they receive a lot of help from MLU, and the ML ecosystem is being developed along with these supports. So company-wide resource support is provided to us, so we're very thankful for that.
Thank you very much. So you have made a technology approach to resolving resource shortages. Have you have had any experience to resolve this problem? Well, to optimize the resources, we are using multiple libraries, and we also have to think about how to train the models. So we provide a lot of guidance to MLOps developers. We use many approaches to optimize the resources. I don't think I can explain everything to you because, and I think Yahoo Japan would be thinking about resource optimization as well. Thank you. Thank you very much. So one of the resource challenges for us is that there would be, for example, 4 GPU servers, and only one GPU is required. So every programs are concentrated on just 1 or 2 GPUs. But then a request comes that requests for all GPU servers. So in that case, we don't know how to resolve it. So that was what the problem was. We did, at the end of the day, resolve the problem, but it was a challenge. The GPU fragmentation was the issue that we have experienced. Now there's another question.
So how much time and how many people did you have to invest in order to be able to use an MLU? So we're not talking about the time it required for one scientist to develop that platform. I think we're talking about how much time it required and how many people you needed for MLU to be used widely. Well, MLU was first created about 3 years ago, and it took about 3 years to develop MLU. It started with the control of the notebook, and then one by one, the machine learning pipeline was expanded, and now we have included deployment and serving and monitoring. So it has become more and more developed. The developers of MLU have been different depending on which point. So in the beginning, it started with less than 10 people, and now we have more than 30 people working on improving MLU.
Thank you very much. So I think we need more manpower and time to develop a platform. And one more question. I'm going to read it out. So when implementing or building workflow related feature, you chose Airflow among many. So what is the reason for this choice? In deep learning and machine learning, Airflow has the most powerful library and features. We did consider Jenkins and other scheduling tools, but we chose Airflow because the features provided by Airflow was right for developing models. However, Airflow is challenging to use. So we tried to make Airflow used as code and GUI tool through our tools, and the code is not written by the developers. The custom operators are provided by MLU. So users can use Airflow's powerful features, but can approach it easily.
Thank you very much. So for GUI, which was prepared for Airflow, I was very curious. So what makes it easier to use Airflow? Well, the operator used in Airflow has each is created with each elements, and operator can be linked by drag and drop, and the pipeline can be set up within the GUI. So within the screen, the parameters can be added, and in the Airflow, everything had to be written in codes. But now, in the pipeline, drag and drop, with a simple drag and drop, you can create it in the pipeline. Thank you very much.
So parameters can be changed from the UIs, and that makes the deployment more easier. Well, I think that's the advantage of this approach.